Hi everybody, today we are going to learn about the law of sines. So just everything that we've done up until now has been involving right triangles specifically. And we have a lot of different strategies for solving right triangles. We learned the Pythagorean theorem that a squared plus b squared equals c squared. We learned about special right triangles, and we learned about trigonometric ratios, which we call SOHCAHTOA. However, what if we are not working with a right triangle? Well, if we don't have a right triangle, we can't use any of those previously mentioned strategies. But luckily, we have two options with non-right triangles. One of them is called law of sines, one of them is called law of cosines. Today, we're just going to talk about law of sines. So if we have a triangle, ABC, and remember when you're labeling a triangle, angle A is always opposite side A, angle B is always opposite side B, and angle C is always opposite side C. And the angles are always uppercase letters, and the sides are always lowercase letters. We can create a ratio between the angles and the sides using sine. We can say that the sine of angle A over side A equals the sine of angle B over side B, or is also equal to the sine of angle C over side C. And we can create an equation using these ratios, and we can solve for a missing angle or a missing side. So there's three cases when we use law of sines, and they are when we're given an angle, and then the next side, when we're given two angles and the side in between, or when we're given two consecutive sides and then an angle. These are the three times when law of sines will work. So let's try this first question. Here, let's start by drawing triangle ABC and labeling it according to the information we are given. So this says angle A is 37 degrees, angle B is 68 degrees, and side C, which is opposite angle C, is 3. They would like us to find side B, which would be right here. So I can see that these two angles, or this angle and this side, can go together. In fact, I can create a ratio. I can say sine of 68 degrees over x. However, I need to set it equal to another ratio. And I'm looking and I know this side, but I don't see this angle. Luckily, we can pretty easily find that angle just by doing 180 minus 37 minus 68. And we should get 75 degrees. And we know that because of the angle sum theorem. We know that the three angles in a triangle should always add up to 180. So now we found a matching angle for this side that we know. So we can say sine of 75 over 3. So from here, all we have to do is cross multiply and solve. So 3 times the sine of 68 degrees equals x times the sine of 75 degrees. And then here I see multiplication, so I'm going to divide both sides by the sine of 75 to isolate x. So we get x equals 3 times the sine of 68 degrees over the sine of 75 degrees. Now, your calculator is going to do the rest from here. You just have to make sure that when you're plugging it in, you close your parentheses after you type in sine of 68, and then you hit divide, and then you can type in sine of 75. If you don't close your parentheses, you're going to get a number that's completely off. So x should be approximately 2.9. Okay, go ahead and pause the video and give this problem a try. All right, so here, check your picture, check your equations, and check how you solved. You should get x to be approximately 8.2. Okay, let's try another problem together. So here, let's start by drawing triangle ABC. And I know that side B is 17 across from angle B, side C is 14, and angle B is 92 degrees. So in this problem, they actually are asking us to find an angle. So I'm going to label angle C theta. But I actually have two pairs of matching information. I know these two things go together and these two things go together. So I can say that the sine of theta over 14 equals the sine of 92 degrees over 17. Now we actually don't need to cross multiply because there's only one thing we can do to isolate sine of theta, and that would be to multiply both sides by 14. When you multiply a whole number to a fraction, it will end up on top in the numerator. So you get something that looks like this. Now if you remember, when we're trying to find the angle, and we've gotten up to this point, we're going to swap those two values and take the arc sine of whatever you see right here. Now I know that this also looks really scary, but this is something that you can absolutely plug into your calculator. Once again, just make sure you are closing your parentheses in the appropriate places, and you should end up with approximately 55.4 degrees. Okay, go ahead and pause the video and give this problem a try. All right, let's check our work here. Once again, we're finding an angle, but we have all the information we need. Check your equation, multiply both sides by 18, and then swap the values and use arc sine. You should get 20.2 degrees. Okay, now for this problem, we're asked to solve triangle ABC, meaning find all of the missing parts. So for this problem, let's start with triangle ABC. Angle A is 33 degrees, angle B is 47 degrees, and side B right here is 14. So we want to first start by finding that missing angle, angle C. And we can do that just by subtracting from 180. And we should get 100 degrees. So now we have two sides we still have to find. We have to find side C and side A. So we are going to need to set up two different equations. So our first one, the information that I know is right here. So I can say sine 47 degrees over 14. And let's say we want to find side A first. I know that side A goes with 33 degrees. So I can say sine of 33 over A. And now I can cross multiply. And then divide both sides by the sine of 47 degrees. And then I can use my calculator to get a decimal approximation. And you should get approximately 10.4. But we still need to find side C. So we'll use that same ratio to start. Sine of 47 degrees over 14 equals the sine of 100 degrees over side C. So now we can cross multiply. C times sine of 47 equals 14 times sine of 100. And we can divide both sides by 47 degrees. And then once again, we can get a decimal approximation of 14 times the sine of 100 divided by the sine of 47 degrees. And we should get approximately 18.9. Okay, that is all for today's lesson. Thank you so much for watching.